Welcome back to Earned Value Management. This is section 4 where I'm going to do more earned value calculation. Okay, so we're back in our same situation where we have a budget at completion of 300 hours. Budget cost of work schedule is 100 hours. And as I said in the previous section, this plan never changes. So there's always 100 hours of budgeted cost work scheduled or planned value that occurs at this time now. In this scenario, the project performs 100 hours of work on schedule. The schedule variance is the budgeted cost of work performed, 100 hours minus the budgeted cost of work scheduled, 100 hours, 100 minus 100 is 0. No schedule variance, that means the project's on schedule, and you can see that here. The schedule performance index is the budgeted cost of work performed divided by the budgeted cost of work scheduled, 100 divided by 100, that should be 1.0. This project is on schedule. In this case, the actual cost of work performed is 90. And we saw an example like this before, where the performance taken was 100, the actual costs were 90. So 100 hours of performance minus 90 hours of actuals is 10 hours. So this product is underrun, on schedule and underrun. The cost performance index is the budgeted cost of work performed divided by the actual cost of work performed. 100 divided by 90 is 1.11. That also indicates an underrun. The estimate to complete computed in this simple formula is simply the budget at completion minus the actual cost of work performed. 300 hours minus 90, there's 200 hours, 210 hours left in the budget. And likewise, the estimate at completion are the actual costs of work performed plus the estimate to complete. 90 plus 210 is 300, and there's no variance because the budget at completion equals the estimate at completion. 300 minus 300 is 0. The to complete cost performance index takes the budget at completion minus the budgeted cost of work performed. 300 hours of budgeted work minus 100 hours of work performed is 200 hours. So right here, there's 200 hours of work left to perform on the project. The denominator is the budgeted completion minus the actual cost of work performed. 300 hours in the budget minus 90 hours spent is 210 hours. So 200 hours of performance divided by 210 hours of budget is 0.95. And what that means is because the project incurred an underrun, is under budget, they could be over budget for the remainder. The cost performance index could be 0.95 for the remainder, and they will still finish within this budgeted completion or the estimate of completion. So, as we did in the previous section, what if instead of giving the project the entire budget remaining, we gave the project a budget based on how much performance is remaining? So if we do the estimate to completion with this second formula, we take the budget at completion minus the budgeted cost of work performed, and this should be 200 hours. Yeah, there it is right there. So budget at completion, 300 hours minus budgeted cost of work performed, earned value, 100 hours, 200 hours left. And to compute the estimate at completion, we add the actual cost of work performed to the estimate to complete. Now we get, this should be actual cost of work performed is 90 hours plus 200 hours. So the answer is right, the computation is wrong. I apologize for that. So it should be 90 hours plus 200 hours is 290 hours. And now we have a positive cost variance because the budget to complete 300 hours minus the estimate at completion 290 hours is 10 hours. And now the TCPI, based on the EAC, is 1.0. The budget to complete minus the budgeted cost of work performed, the amount of performance remaining is 300 minus 100. 300 of budget minus 100 of performance is 200 hours of performance left. Divided by now the estimate at completion, which is 290, minus the actual cost of work performed, which is 90. That's 200 hours. So 200 divided by 200 is 1.0. So the project had been performing at 1.11. If they perform at 1.0, they will finish within this new revised estimate of completion, 290, and the project will finish with an underrun of 10 hours. So like we did before, what if we wanted to take credit for this good performance on the project? We do an independent estimate to completion. So here, we take the amount of performance remaining, the budget of completion, minus the budgeted cost of work performed, and we divide by this cost performance index. So the budget of completion minus the budgeted cost of work performed is 300 minus 100 is 200. 200 hours of performance left. And now we divide by the cost performance index, 1.11. So instead of getting 200 hours, we now get 180 hours in the ETC. And now the EAC goes down as well. The independent EAC is the actual cost of work performed, 90 hours, plus this new ETC, 180 hours. Now the budget is 270 hours instead of 290. So we've taken another 20 hours out of the ETC and the EAC based on this calculation. So now the variance at completion is the original budget minus the estimate at complete. 300 minus 270 is 30 hours. And now the TCPI is the budget at completion, total budget, minus the budgeted cost of work performed, which is 300 minus 100, 200 hours of performance left on the project. And now the new IEAC is 270 hours left in this new budget, minus the actual, which you've already spent, which is 90. 270 minus 90 is 180 hours, and we knew that from the ETC. So 200 hours of performance divided by 180 hours in the budget is a TCPI of 1.11. So with this new revised estimate, what this says is the project needs to keep performing at this higher rate in order to close on this new budget. And if they keep performing at this higher rate, they will underrun by this variance of 30 hours. So one thing you'll notice is that on this new plan, we need to see a CPI in every period, every future period that's reported of 1.11. We always assess earned value performance based on the original plan. So despite the fact that we're being more efficient, we don't revise this plan. This budgeted cost of work schedule always remains the same, and it always will finish at 300 hours. Likewise, when we take performance, if we finish the project, the most performance we can take is 300 hours. This too never gets revised. What we can revise is this estimate of completion. And in the previous case, we had a TCPI of 1.0. Well, that would look kind of normal. We'd have a CPI of 1.11 for this period. But if the project manager went back on plan and stayed at a 1.0, they would finish at that underrun that I think was 10 hours. In this new case, though, we're expecting that this performance persists through the end of the project. That means that every reporting period, the CPI will keep remaining at 1.11. And in fact, because we revised this EAC downward to 270, the project has to perform at 1.11. So in some cases, you could replan the project. And you could say, okay, I'm going to reduce the budget so that the CPI is now 1.0. That changing these is a pretty significant thing to do. It's better to keep the plan baseline, so you always have something to compare against. You always know what your original estimate was, and just track the progress on the project going forward at a CPI of 1.11. So here, to meet this budget, we're going to expect 1.11. And now, if the cost performance index falls below 1.11, that would be an overrun to this new estimate of completion, or the CTC. If the performance falls below 1.11, it means we won't get this 30 hours of underrun. Okay, another example. Again, BCWS is always 100. The plan value is always 100. That never changed. The budget of completion is 300. That never changes. In this case, the project has only taken 90 hours of performance. So it's behind schedule. The schedule variance is the budgeted cost of work performed, the 90 hours, minus what was scheduled, 100 hours, a minus 10 schedule variance, which means the project is behind schedule. Likewise, the schedule performance index is 90 hours of work performed divided by 100 hours of work scheduled is 0.9, behind schedule. In this case, however, the actual cost of work performed is 90 hours. So the cost variance is 90 hours of work performed, 90 hours spent to perform that work is 0. So we went through this example before where the project is behind schedule but is not overrun and is not underrun. Likewise, the CPI is the work performed 90 hours divided by the hours spent, 90, is 1.00. So behind schedule but on cost. And again, this might look like an underrun because only 90 hours were spent when 100 hours was planned. But if you account for the earned value for the work performed, this project is within budget and right on budget. So the simple estimate to complete is just the budget of completion minus the actuals. 300 minus 90 is 210. The estimate at completion in this case are the actuals plus the estimate to complete. 90 plus 210 is 300. And you'll notice this ETC and EAC are kind of redundant. You know, you do one subtraction to get the ETC, you do the opposite addition to get the EAC. We compute ETC because we want to predict the budget going forward to the end of the project. We compute EAC because we want to be able to compare the EAC, the estimate at completion, to the budget at completion, and determine if there's a variance in how we're going to complete the project. So in this case, because we performed 90 hours of work, we spent 90 hours of work, the budget remaining accounts for the 210 hours of performance remaining. So the budget of completion minus the budgeted cost of work performed, 300 hours of budget minus 90 hours of performance is 210. So there's 210 hours here. Likewise, the budget of completion minus the actual cost of work performance is 300 minus 90. there's 210 hours of budget remaining. 210 divided by 210 is 1.0. So in order to come in on budget, this project has to perform at a cost performance index of 1.0. And here's the variance. So this project is behind schedule. And what if we were concerned about that? There's another way to compute ETC by taking, you recall we computed ETC here by taking the performance remaining and dividing by the cost performance index. This computation takes the performance remaining, the budget, minus what was performed, that's this area here, and divides by the schedule performance index, which here is 0.9. So let me show you what. Okay, so my original ETC was 210. In this case, and here if I just done ETC based on performance, I still would have gotten 210. But now I want to divide by the schedule performance index. So the budget minus the performance is 300 hours of budget minus 90 hours of performance is 200. If I divide by 0.9, I get a new ETC of 2.33. So what this says is the project manager is going to have to spend more money to get back on schedule. They've been doing great. They performed 90 hours of work by only spending 90 hours, but they're behind schedule. So in order to get things done more quickly, let's just assume they're going to have to add more resources. And we estimate that in order to compensate for this 0.9 schedule performance index, they're going to have to add 23 hours to the plan. So now the new estimate of completion is the actual cost, 90 hours, plus this new ETC, 233 hours, 323 hours. And the variance is now 23 hours. So in order to get back on schedule, we have to increase this budget. It means we're going to overrun by 23 hours. And maybe that's okay. Maybe schedule is the most important thing to us. Maybe we have 23 hours to spend. Now the to complete CPI is the budgeted completion minus the budgeted cost of work performed. So 300 hours of budget minus 90 hours of performance. There's 210 hours of performance remaining. So the project should have gotten 100 hours completed. There should have been 200 hours of performance remaining because only 90 hours of performance were completed. There's 210 hours of performance remaining. But we've increased the EAC. The EAC is now 323 hours, and we did that by looking at the performance remaining and dividing by the scheduled performance index. 323 hours remaining, we've only spent 90 hours. There's 233 hours remaining in this budget based on the estimate of completion. And the CCPI is based on IEAC. So if we have 210 hours of performance and we have 233 hours of budget, our to complete cost performance index is 0.9. So what that means is, despite the fact that the project manager had a perfect cost performance index, if we want to get back on schedule, they can meet this budget by performing at a cost performance index in the future of 0.9. Now, personally, I don't like to equate schedule performance to cost performance like this. In the previous example, we had divided this performance remaining by the cost performance index, and there you're comparing cost to cost. And in order to, if the project had been at a cost performance index of 0.9, it's pretty valid to compute the ETC by dividing by a cost performance index of 0.9. Schedule, there could be a number of reasons why the project's not on schedule, and it might not help to add 23 hours of budget to the project. There might be some other reason it's behind schedule. If it's purely a financial reason, then this is somewhat reasonable, but it's not a calculation that I would necessarily recommend. Nonetheless, I wanted to show it to you because it is one of the methods for computing estimate to complete. Okay, another example. So these are all of our ETC calculations that I've shown you thus far. Again, our budget's 300. Budgeted cost of work scheduled is always 100. That's our plan value. In this case, the budget cost of work performed is 110 hours. So we're ahead of schedule. The schedule variance, the work performed minus the work scheduled, is 110 minus 100. We're 10 hours ahead of schedule. Our scheduled performance index is the work performed divided by the work scheduled, 110 divided by 100. So our scheduled performance index is 1.1. Here, the actual cost came in at 100, and there should be a little 100 over here. So the budget cost of work performed was 110. We got more work performed than was in the plan. We only spent 100 hours to do it. That's a 10-hour underrun. And the cost performance index is the performance divided by the actuals. 110 divided by 100 is 1.1, and there it is. So here, we're ahead of schedule because we performed more work than was planned. And because we spent 100 hours to do 110 hours of work, we're underrun. So this is a nice scenario. both ahead of schedule and underrun. The estimate to complete in the simple formula is 200 hours. That's just the budget minus the actuals. 300 minus 100 is 200 hours. The estimate at completion is going to be 300 hours. If we add back the actuals to the estimate to complete, we get 300 hours, which is identical to the budget completion. So there's no variance here. The to complete cost performance index is the budgeted completion minus the budgeted cost of work performed. So 300 hours of planned work, 110 hours of earned value taken, there's only 190 hours of work remaining on the project. Yet, the budgeted completion of 300 hours minus 100 hours of actuals, there's 200 hours of budget. So because we have 190 hours of work remaining and we divide that by 200 hours of budget remaining, the to complete cost performance index is 0.95. So because this project manager incurred an underrun, got more work done for less cost, they could perform at a CPI of 0.95 for the remainder of the project and meet this 300-hour budgeted completion. All right, and so the variance. So let's look at this a little more. In one of the previous examples, we had adjusted the EAC based on a 0.9 cost performance. Now we've got a project manager that's doing 1.1. So let's do our IETC calculation again. So we're going to take the budget at completion minus the budgeted cost of work performed. So it's 300 minus 110 because we performed 110 hours of work. And we're going to divide by the CPI of 1.1. Now the ETC is 172 hours. So not only are we not computing the EAC just based on the 200 hours of budget that's remaining, not only are we not computing this ETC based on the 190 hours of performance remaining, we're dividing by this cost performance index of 1.11 because we believe the project is going to maintain that performance going forward. So now the IETC is 1.72 or 172 hours. And the EAC is adjusted accordingly. So the EAC is the actual cost, 100 hours, plus this new ETC, 172 hours. The new EAC is 272 hours. And the variance now is 28 hours. So with this new estimate, we're predicting that we're going to be 28 hours underrun. And that's because the project has been performing at a cost performance index of 1.1. And we assume that's going to continue into the future. So now the TCPI is the budgeted completion minus the budgeted cost of work performed. So 300 hours of work planned in the budget, a performance planned in the budget, minus 110 hours of performance taken. There's 190 hours of performance remaining in the budget, and that's here. The IEAC is 272 hours. That's the EAC based on this calculation and dividing by the current CPI, minus the 100 hours of actuals. So now we've only got 172 hours left in the budget to perform 190 hours of work, and the going forward CPI is going to need to be 1.1. And that's exactly what we had intended to do. The project has been performing at 1.1. We assume that's going to continue. We revise this budget downward. And as I said before, if you're going to measure progress on this project, and if you're going to want to complete at this new budget of 272, the CPI going forward is going to have to remain at 1.1. So if the CPI is at 1.05, that's actually going to indicate that the project is going to overrun this new 272-hour budget. Okay, again, I've got a budget of 300. The budget cost of work scheduled for time now is 100 of planned value. Now the budgeted cost of work performed is 90 hours, so we're behind schedule. Schedule variance is the work performed minus the work scheduled. 90 minus 100 is minus 10 schedule variance. Schedule performance index is 90 hours of work performed divided by 100 hours of work scheduled is 0.9. And in this case, the actual cost to perform that 90 hours of work is 110 hours. So this project is behind schedule and is significantly overrun. The cost variance is the work performed minus the actual cost to perform that work. 90 hours of performance taken minus 110 hours of hours spent. Now that's a minus 20 hour cost variance. Cost performance index is the 90 hours of work performed divided by the 110 hours of actual cost. Cost performance index is 0.81. So this is the biggest overrun we've seen in these examples. So the estimate to complete based on the simple formula is the actual cost, or the budget minus the actual cost. 300 hours of budget minus 110 hours spent is 190 hours. The estimate at complete is you just add the actuals back to the estimate to complete. 110 hours plus of actuals plus 190 hours of ETC is 300 hours. And here the variance is obviously 0. So the to complete performance index is the budget completion minus the performance taken. 300 hours of performance in the plan minus 90 hours of performance taken is 210 hours of performance remaining in the plan, divided by the budget, 300 hours of budget, minus the 110 hours of budget spent is 190 hours. So there's 210 hours of performance remaining in the plan, divided by 190 hours of budget remaining. The to complete cost performance index is 1.1. So this project manager had been performing at 0.81, and in order to close on this budget, they need to perform at 1.11. That's a significant increase in cost performance. So in some respects, you might say to a project manager, look, you screwed up. You've only got 190 hours of budget remaining. You got to make that work. And you challenge them to find a way to improve performance. And maybe they do the work with less people. Maybe they work weekends. They don't get paid for it. But by and large, if they're really consistently performing at this level, it's very unlikely they're going to perform at a 1.1 level. And two, they're not only overrunning, they're behind schedule. So how do we remedy that? All right, so we're going to use all of our methods to look at the various ways we can increase ETC and increase budget. So again, if we use the second formula, we would take the budgeted performance of 300, we'd subtract the actual performance of 90, and we'd come up with an ETC of 210. So again, that says if the project performs at a CPI of 1.0, then all they need is 210 hours of budget. So we take this new ETC of 210, we'd add it to the actuals. So 210 plus 110 of actuals, the new estimate at completion is 320. That's a 20-hour cost variance. And now the TCPI is 1.0. So that's the budget minus the performance, 300 hours of planned performance minus 90 hours of performance taken. There's 210 hours of performance remaining. The new budget, EAC, is 320 minus the 110 hours of actuals. There's 210 hours of budget remaining in this scenario. That means in order to close on this new budget, this new revised estimate of completion, the project has to perform at a CPI of 1.0. Well, the performance has been 0.81. 1.1 is a stretch. Even 1.0 is a stretch. So what if we wanted to do more to predict better where this project's going to come out? All right, so we do the calculation we talked about before, where we take the performance remaining and we divide by the cost performance index. So here the budget complete was 300 hours of performance in the plan. The performance taken was 90 hours. 300 minus 90 is 210, and now we divide by the cost performance index of 0.81, and we get a new ETC of 259 hours. So that's a pretty significant increase. We add that ETC of 259 to the actuals to get a new AC. So the actuals of 110 hours plus the new ETC of 259 is a new estimate of complete of 369 hours. And now the variance is 69 hours. So the new to complete cost performance index is the budgeted performance of 300 hours minus the actual performance taken of 90 hours, which is 210. So that's this right here, 210 hours of performance remaining, divided by this new EAC of 369 minus the actuals to date of 110. So there's 259 hours of budget remaining to perform 210 hours of work. And if you divide 210 by 259, you get a to complete CPI of 0.81, which equals the historical cost performance index. So what that says is, in order for the project to meet this new revised estimate of complete, the cost performance index going forward has to be 0.81, which is what it's been in the past. So that's consistent performance. So again, we could replan the budget cost of work schedule, and the CPIs could be 1.0 in the future, going forward in the future. But we don't like to replan. It's much better to baseline the plan, leave the plan in place, and going forward, just measure the project based on a cost performance index of 0.81. So in this case, if the performance in, say, the next month was 1.0, that means that the project's going to underrun to this new plan. And if the performance was 0.7, that means that the project's going to overrun to this plan. So you use 0.81 as the target CPI going forward. All right, so that accounted for cost. The project's also behind schedule. So the project's overrun and behind schedule. So we had a schedule variance of -10. We have a cost variance of -20. What if we wanted to solve both? Well, we'd use this new formula up here. So this takes the performance remaining, which is the budgeted performance minus the performance taken, the budgeted cost of work performed, and divides by the scheduled performance index times the cost performance index. So this takes both schedule performance and cost performance into account. So if we do that, we're behind schedule, we're overrun, so we take 0.9 times 0.81 as the denominator. We take 210 hours of performance remaining, we divide by this product, and now we get 288 hours of estimate to completion, so even significantly higher. If we add that to actuals, our new estimate at complete is 110 hours of actuals plus 288 hours of estimate to complete. That's what we think it'll take to finish the project. And the new estimate of completion is 399 hours. So the variance is now 99 hours. So that's a 33.3% increase to the budget. That will get us back on schedule, and it'll more accurately predict what our costs will be. So now the TCPI is the budget, the planned earned value in the budget, 300 hours, minus the earned value taken, 90 hours. So there's 210 hours of performance remaining on the project. And now our EAC is 399. We subtract 110 of actuals. We have 289, it should really be 288, but 288 hours of, yeah, I got a math error here. But anyway, I'm off by an hour. 289 hours remaining in the budget. The cost performance index going forward that we have to achieve in order to meet this 399 hour budget is 0.72. So what we're saying is the project can perform even worse than they had in the past because we want to get back on schedule. So they will add more resources, spend more money, and now the metric that we compare them against is 0.72. Now, in some case, if this number starts getting really low, then you would do a replan. Because obviously, the project was underestimated, the schedule was too aggressive. If the numbers get down to even below 0.5, then you probably would want to do a replan because these numbers start to be less meaningful when they get really, really low. But anyway, to get the project back on track, it's going to cost another 99. Okay, there's one more way to do an estimate of completion, and it's a bottoms-up estimate at completion. So let's go back to the case where we're actually building widgets, and we can take earned value very clearly. We planned to do 100 widgets. We accomplished 100 widgets. The planned cost was 100 hours. The actual cost was 110 hours. Again, we plan to do 100. We do 100. The actual cost is 110 hours. We plan to do 100. We do 100. Actual cost is 110 hours. So you can see a trend here. It's not likely that we're going to meet this 100-hour estimate going forward. So what we do is a bottoms-up EAC, and we say, you know what, we looked at it, and it's not 1 hour per widget. It's actually 1.1 hours per widget. So in the new revised EAC, this isn't based on SPIs or CPIs or variances. It's not based on budget remaining. It's purely based on what we think it's going to take to do the work going forward. And many times, this is the best estimate. The metrics, doing ETCs and EACs based on CPI and SPI is a good way to forecast, but many times past performance is not a good predictor of future performance. And if you've got somebody who can really estimate things bottoms up, it's more effective. So here we don't revise the plan, but we now have a new EAC which accounts for our new estimate. And so we build 100 widgets at 110 hours, 100 widgets at 110 hours, and it looks like our bottoms-up estimate was right. So this is one more method, and probably the most common method for doing a revised